You're watching the New Stack Makers, a podcast for people who develop, deploy, and manage at-scale software. For more information and articles about at-scale technologies, please visit thenewstack.io. Now enjoy the show.
Since its inception, Amazon Web Services, AWS, has been the best place for customers to build and run open source software in the cloud. AWS is proud to support open source projects, foundations, and partners.
Okay, back at KubeCon, I'm with Jesse Butler.
Hello.
Hey, Jesse. Jesse's with Amazon Web Services, and Jesse and I are going to first talk about the good old days. Way back when you didn't even have to think about autoscaling. What were those days like?
Sure, simpler.
Simpler?
Yeah. But it's getting simpler now, so that's what we'll talk about as well, right?
Yeah.
It was simple, then it was hard, and now it's getting simpler again, which is good.
So when did you first, like Kubernetes is now 10 plus years old.
Mm-hmm.
From the beginning was supposed to be a scale-out architecture, right?
Yeah.
But when did it really start to mature so auto-scaling became far more relevant?
And I think almost from the beginning, right? Because so as you're using this extensible, open, portable thing that was still being built at the time,
right?
You need compute,
right?
And you wanted that to be dynamic. So starting with things like static capacity and saying, oh, I'll probably need 10 of those, quickly turned into, I don't know what I'm going to need, right? That's kind of one of the aspects of cloud native workloads in general. Like they're spiky, they're dynamic, and you want that automation, which Kubernetes promises through its extensions and the KRM, right? You want that to be dynamic along with your workflow. So I think almost from the beginning, people started trying to solve this problem. And I think like Cluster Autoscaler came along and it was like, okay, that's a good place to start, right? That was a good standard to leverage.
So today we're going to talk about Crow and Carpenter, and let's first talk about Crow. And
sure.
And it stands for Kube Resource Orchestrator.
Mm-hmm.
When did you start? When did your teams start to see the need for something like this?
Quite a while ago. So I think back on sort of like what Kubernetes promises through the KRM and its extensibility, very early on, first couple of years, we started looking at people, once the CRD came along, custom resource definition.
Right.
You write your own controller,
right.
Define your own custom resource. You could do everything with that. And we knew it right from the beginning. It's like, yes, it could be a specific type of Kubernetes workload resource that's just for your organization. That also could be something that represents some on-prem infrastructure, network switches, SAN volumes, like outside of EBS or the CSI or cloud services like EBS. And then pretty quickly, it did get to the cloud and you say, well, like what Crossplane did, right? And they said, hey, this can be an API server or a control plane for everything. And then the next thing you know, you have everything from cloud infrastructure and basic fundamental resources all the way up through like ordering Domino's pizzas, right? Like you could do anything with this model. And so pretty quickly, we started having customers and end users, talking about, hey, I've got this custom resource and I've got that custom resource. And together, they make up part of my application stack. I want to bind them together, right? I want to actually manage these together. So now you start building a custom controller with a CRD to just glue other resources together. And that works. And it's not super big rocket science, but it is a specialized skill set. And it is, as an organization, also code that you now own, right? Any config and code, if you're not implementing business logic, you might consider that to be tech debt, right? Now, it worked at the time, and it was the right thing, but some of our customers, even 4 or 5 years ago, had 20 or 30 custom resources. So you have some small team inside of a much larger organization that just owns this code that isn't really business logic. So we thought, how do we solve for that? And there's a lot of solutions out there that do try to solve for that in different ways. So we were a couple of years ago thinking about kind of a new primitive and taking some of the learnings that we've had from our operational scale and running Kubernetes for several years at the scale that we do, We thought, what can we do for the whole community that is like a new primitive? Not a whole new project with its own logo and a competing interest, but more like something that you just put in the cluster and everybody can leverage. So that's where Crow came from. And it really tries to solve a few different problems around controller proliferation and resource orchestration.
So that's why you didn't want to make it part of a product, right?
Exactly, yes. Like we might do that at some point in the future, but it would be based on that open project.
Right.
The thing that is just part of Kubernetes or Kubernetes adjacent.
I don't want to go too far into the detail behind Crow, but
Sure.
there are some characteristics of it that are noteworthy. For instance, microcontrollers.
Mm-hmm.
Could you talk about the role of microcontrollers?
Sure, yeah. So I think we knew very early on what we didn't want to do was like a non-Kubernetes native thing, right? We wanted to use that same pattern that we know, a CRD and a controller. So if we look at it from kind of first principles and that problem statement, what we decided to do is build a solution that will automatically create a CRD and register it for you and manage its lifecycle. And then automatically create a microcontroller inside of itself to manage that custom resource. So that's kind of, at a high level, that's what Crow does. Our lead engineer invented this new thing called the simple schema. So that allows you to, in YAML, define what you want your CRD to be. And then the other part of that single resource, which we call a resource graph definition. The top part is the spec, which is the CRD itself, and then the bottom part is your resources, the constituent resources that make up that custom resource. So in that, with those resources, Crow will actually look at those, kind of infer the ordering and their dependencies based on the configuration that you've set. It creates a DAG and says, okay, that's that resource graph. So you marry that with the spec that you defined. That's your CRD and the resources that you're going to manage with that microcontroller.
Okay.
So what I'm saying is under the covers, it's all the same Kubernetes principles that we know and love and that have worked really well for 10 years or 8 years.
So that would make it very applicable to a platform engineer, for instance.
That's kind of the target market. Yeah, that's like, hey, we know this is a problem for you. What do you think of this solution? And that's where we see a lot of people are starting to adopt it. Crow right now is at 0.6.
Yeah, it's pretty young.
0.6.1 maybe. And we have like one more major feature to build.
Okay.
Which is around version management and rollouts of version changes. Once we're there, it's pretty much code complete. So we've been saying, hey, there could be breaking changes. Use at your own risk. Do some POCs. We have I know a lot of people running it in production right now, which is okay. But we did the same thing with, for example, Docker when it first came out, right? Solomon said it's 0.1, don't run it in prod, it's not ready, and it was great. So it took off. And I think that's not that Crow is like Docker, but we're seeing that sort of uptick with a specific niche of end user, which is like the platform engineer, trying to build these layers of abstraction.
So let's turn to Carpenter.
Sure.
And I was actually at some of the sessions yesterday for day 0, and there were people talking about Carpenter.
Mm-hmm.
I think that's pretty cool.
It's very cool.
And what is it about Carpenter that makes it popular for people?
Yeah, I think, well, a couple of things. Really similar to how we kind of came up with the idea for Crow. A couple of our very smart engineers several years ago were looking at autoscaling, and we thought, what if we have a different approach, right? Not necessarily replacing the autoscaling patterns that we have now, but what if we look at a broader picture and start provisioning nodes on demand based on scheduling pressure, right? If you throw a pod at the cluster and it can't be scheduled because there's no node, let's go provision one. And so that was sort of the impetus of Carpenter. It started as a couple of different POCs, but that's where really it ended up being that's the solution, that's the answer. And so as it started expanding and gaining traction, we realized pretty early we'd need a provider model, right? If we wanted this to be a Kubernetes feature, it can't just speak to EC2 APIs. So the provider model came along. But I think those are the two pieces, right? One is kind of the way that we solve the problem of saying, like, we're going to autoscale through kind of just-in-time node provisioning, and also deprovisioning, right? If the workload slows down, we can deprovision your nodes and save you some money. We also realized very early that we could build logic into the controller and the solution overall that would help you choose the right node, not only based on sort of performance requirements, but also price characteristics, right? So then you start having this sort of, oh, this can actually save me money. It can save me operational burden, and it can actually make it cheaper to run my Kubernetes cluster. So that was a big part of it. And then finally, I think just through the API design, it's quite elegant, it's very simple, but it allows you to get very complex. So because node management, it's, do you want just a node? Fine, have it. Often you have to get a little deeper. Okay, I need these types of CPUs, I need this much memory. Even deeper, I need these types of hardware characteristics, right? So the API lets you just be as simple as you want. Hey, just give me a node, whatever it'll do. And it can get all the way into really fine-grained detail of that node configuration. So having all of those things kind of presented through this nice API, solving this problem in a really novel way, I think is what helped really kick things off. And very quickly after that, we were talking to SIG Autoscaling and saying, hey, cluster autoscaling and SIG, how can we help you? Like, is this an interesting idea? And one thing led to another, and that's sort of where the project ended. So.
It always strikes me how compelling cluster management it is as a topic for people such as platform engineers, for DevOps professionals. It's historically been pretty complicated.
Yes.
Is that one of the reasons why Carpenter was really developed in the first place?
I think so. It's part of the mission of Crow as well. It's part of the mission of our auth work upstream that you'll talk with Micah about as well. Like, we're really trying to help simplify things, right? Because we just see such a massive adoption of Kubernetes. This is no longer like a market segment or a certain type of organization that's using Kubernetes. Everyone's using Kubernetes.
Right.
And so when you get there, it's almost like with Linux, right? It was not, it's a long time ago. For me, it's just yesterday when major banks were building their own Linux kernels because there were no distros, but they knew they wanted to use Linux. And it's like, okay, they were pioneers. And now, you look, it's just the way the world works. Everybody's got a commercial Linux distro. That's what we all run on. I think Kubernetes is kind of there as well, right? We've gone from kind of building our own bespoke cluster API servers and our own control planes to like looking for standards to build at scale for our enterprises. And that same software works for the stealth startups that are just starting to scale, right? That's sort of the magic of it. So I think that's what we're always looking for, is a way for EKS to leverage some of its operational understanding and our expertise to help move that ball forward and making things simpler through standards.
So it's maturing it has matured quite a bit.
Carpenter, I would say, yes.
But there's still issues that you're trying to resolve, like operational overhead and API stability. How are you addressing issues like that?
I think API stability has always been something that we, since we cut 1.0, we said, okay, that is now a stable API, we must respect that. So I think we did a lot of very deep thinking ahead of that point in time to make sure that we had all of the flexibility to evolve the project in a way to solve problems in the future, right? And I think we've done a pretty good job of that. So this year we've got a few very specific enhancements. We have node overlay, which is a big change, which is a backward compatible change that allows you to optionally overlay characteristics of node selection, node criteria, things like, for example, if you have specific third-party pricing in a cloud service, right? You can actually put that in place. Carpenter wasn't able to do that before, and through that API extension, you're able to now. So that's sort of an example of evolving this to actually simplify things, to make it more broadly acceptable or applicable to various use cases. We also have a new capacity type where ever since we first started the project, it's always done dynamic capacity, right? So it's on demand. When you have a pod that can't schedule, we go get you a node. We now have a static capacity option to allow just a little bit more flexibility, a little more simplicity. If dynamic doesn't work for your use case, you can choose static, and you can kind of pre-allocate compute resources. So we're kind of always looking for ways to expand, but keep the API stable. So that comes through, just like other Kubernetes or other software APIs, right? You're looking for optional additions, things that augment the existing core functionality.
I guess in conclusion, I just would like to touch on a little bit about how the open source philosophy has evolved at AWS and how Carpenter and Crow reflect that. Carpenter, for instance, is a CNCF project, right? 10, 15 years ago, it would have been very unlikely for any large company to donate a project like that. It wasn't. There were some. It was being done, but now it's a whole different world. What makes this world so different that it allows a company like AWS to say, "Yeah, we're just going to give this to the CNCF"?
That's a good question. I think looking at open source in AWS. From the position that I have inside the company, it's very important to us. We put a lot of resources into it whenever we can, particularly based on customer needs. Kind of from the outside, it's not that obvious. And I will say that. I'll be the first to admit that. Sometimes it's a difficult story to tell, right? But depending on where you look in the company, you can see evidence of that culture of just trying to solve customer problems come through. So in the case of EKS, which I joined EKS in 2020, Carpenter had just started, Crow more recently. These are solutions that originated in that space of trying to solve customer problems. And if we think about customer problems in context of Kubernetes and cloud native software and all of this around us, it is community. Right, we can't very well just build something for our product and say it's Kubernetes, right?
Yeah.
You have to actually build that way.
That's not real value.
It's not. Yeah, exactly. It's not a marketing play, right? It is just how this stuff works. That's how the stack works. So when we look at the opportunities that we have to invest heavily in something in open source, it's always going to be one of those things that is good for the community. Ideally, will help Kubernetes move the ball forward in some way. And we're always looking at a Kubernetes donation. So with Carpenter, we had thought about it. Should it be a CNCF sandbox project versus being, in a Kubernetes SIG? We said, no, this is very clearly part of what we envision an ideal Kubernetes experience to be. It's not optional, right? And so that's why we said, hey, SIG, cluster autoscaling, that's the place for it. We did the same thing with Crow. We said, hey, this feels like a missing feature in the cluster. We don't want to build a whole new end-to-end world and a whole control plane product. We just have this one cool idea that we think will help everybody build those things. So we knew right from the beginning, not only would we open source it, we would point it at the CNCF. And would it be its own sandbox project? No, this feels like something that helps Kubernetes as a feature. That's why we pointed that at SIG Cloud Provider, because that's where we see most of the resource orchestration problems coming from, is in managing cloud resource state inside of a cluster. And so Crow, this past summer, we donated Crow to SIG Cloud Provider. So that's a pattern that I'm really excited about. Being in the EKS team and helping to evolve some of these ideas, is that we're able to find the place where, like, hey, there's a problem we want to solve. Let's not only open source it, let's see if we can just do the best job we can at making it something that the whole Kubernetes ecosystem is interested in, and then we land it in a SIG, where it's just a primitive, a feature, a specific solution that can help Kubernetes kind of move on to the next 10 years, right? Not to wax too poetic, but that's kind of the mission, right? Is how do we keep moving this thing down the road?
That's very well said. Well, Jesse, thank you so much for taking this time. It's been
always
fun.
Good to see you. Thanks so much.
If you like this video, please give us a thumbs up. And if you'd like to see more videos like this, you can always subscribe to our YouTube channel. We're on all the major social media platforms. You can always find us at thenewstack.io. We hope to see you soon.